Picture North America, not as a bustling continent, but entombed beneath a colossal ice sheet, stretching endlessly to the horizon. This was the stark and unforgiving reality of the last ice age, an era of relentless cold that gripped the planet for millennia, transforming the world into a desolate, frozen wilderness. Enormous glaciers, rivers of ice miles thick, carved through the land with unstoppable force, leaving an indelible mark on the landscape we witness today. These glaciers, driven by unimaginable pressure and gravity, acted like colossal bulldozers, gouging out valleys and pushing earth and rock before them, reshaping entire regions with their might. As the planet oscillated between warmth and cold, these ice sheets advanced and retreated, each cycle dramatically altering the face of the Earth, leaving behind a transformed terrain. The legacy of these icy behemoths is etched into our world, most strikingly in the form of glacial lakes, vast bodies of water born from the melting ice cradled in mountain valleys. These lakes, some of which dwarfed modern-day seas, played a pivotal role in sculpting the landscape and ecosystems we see today, profoundly influencing the environment in ways we are only beginning to understand. Of all the ice sheets that dominated North America during the last ice age, none were as massive or as awe-inspiring as the Laurentide Ice Sheet. This behemoth of ice at its peak covered most of Canada and extended south into the United States, reaching as far as present-day New York and Chicago. It was a colossal force of nature, shaping the very landscape beneath it. Its sheer size is difficult to comprehend, a frozen expanse that boggles the modern mind. Imagine standing on an endless plain of ice, stretching as far as the eye can see. Imagine a single sheet of ice, miles thick, pressing down on the land with unimaginable weight. The pressure was so immense that it caused the Earth's crust to deform. As the Earth's climate began to warm, the Laurentide Ice Sheet, like other ice sheets around the world, began to melt. This melting marked the end of an era and the beginning of dramatic changes in the landscape. This melting, however, was not a uniform process. It was a complex and uneven retreat, influenced by various factors including temperature and geography. The edges of the ice sheet, where they met warmer temperatures, melted faster, creating massive pools of meltwater. These meltwater pools were vast and often unpredictable. These pools, trapped by the retreating ice front and the natural topography of the land, became the progenitors of some of the largest freshwater lakes the world has ever seen. Lakes that continue to shape the environment and provide vital resources to this day. Imagine the scene. The massive wall of the Laurentide Ice Sheet, towering hundreds of feet high, slowly retreating northward. In its wake, a landscape transformed. The immense weight of the ice had pressed down on the Earth's crust, causing it to sag. As the ice melted, the land slowly rebounded, but this process was slow, leaving behind vast depressions that filled with the meltwater. These depressions, carved and molded by the relentless movement of glaciers, became the cradles for glacial lakes. Some lakes formed in front of the ice sheet, dammed by ice or glacial debris. Others formed in depressions left behind as the ice retreated. These were not mere ponds or small lakes. These were inland seas, dwarfing many of the largest lakes we know today. Among the most significant of these glacial lakes were Lake Agassiz and Lake McConnell. Lake Agassiz, named after the renowned Swiss-American scientist Louis Agassiz, was a true giant, larger than all of the modern Great Lakes combined. At its peak, it covered an area larger than the Caspian Sea, the largest lake on Earth today. To the west of Lake Agassiz lay Lake McConnell, another massive body of water that played a critical role in shaping the landscape of North America. These lakes, however, were not static entities. As the ice sheet continued to melt and retreat, the boundaries of these lakes shifted and changed. Sometimes they would overflow, their waters carving new channels through the landscape, altering the course of rivers and gouging out valleys. In other instances, they would drain catastrophically, releasing unimaginable torrents of water that rushed towards the oceans, reshaping the land and influencing global sea levels. As the colossal Laurentide Ice Sheet began its retreat, its meltwater carved new paths, flooding into the Mississippi and Ohio rivers, reshaping the ancient landscapes and altering the course of North America's rivers and terrain. The melting of the Laurentide Ice Sheet and the subsequent formation and drainage of glacial lakes had a profound impact on the river systems of North America. The Mississippi River, for instance, owes its current course in part to the drainage of Lake Agassiz. As the lake overflowed, its waters carved out a new channel, redirecting the flow of the Mississippi and carrying vast quantities of sediment southward. The Missouri and Ohio rivers, major tributaries of the Mississippi, were also impacted by glacial meltwater. These rivers carried massive quantities of sediment eroded by the glaciers and transported by the overflowing lakes, depositing them in the Mississippi Delta and contributing to the fertile lands that characterize the region today. The very shape of North America, its river systems, and the contours of its landforms bear the indelible imprint of these glacial processes. As vast meltwater pulses poured into the seas from receding ice sheets, global oceans surged, sparking dramatic shifts in currents, climate patterns, and coastlines that extended far beyond North America, forever altering the world's marine and atmospheric balance. The impact of these melting ice sheets and draining glacial lakes extended far beyond the confines of North America. As unimaginable quantities of freshwater poured into the world's oceans, global sea levels rose. These were not gradual rises, but sudden, dramatic pulses of meltwater that had a significant impact on ocean currents, global climate, and the distribution of plant and animal life. These meltwater pulses, sometimes referred to as global floods, had a profound impact on the planet. They altered ocean salinity, disrupted ocean circulation patterns, and likely contributed to rapid climate fluctuations. The evidence of these events is recorded in marine sediments, in the drowned coastlines of continents, and in the genetic makeup of marine organisms, a testament to the interconnectedness of Earth's systems. A sudden and intense return to glacial conditions interrupted the warming trend at the end of the last ice age, plunging the Earth back into a deep chill. This unexpected cold snap, known as the Younger Dryas, remains one of the most profound and puzzling climate shifts in history, sparking theories about cosmic impacts, ocean circulation changes, and volcanic eruptions. A sudden and intense return to glacial conditions interrupted the warming trend at the end of the last ice age, plunging the Earth back into a deep chill. This unexpected cold snap, known as the Younger Dryas, remains one of the most profound and puzzling climate shifts in history, sparking theories about cosmic impacts, ocean circulation changes, and volcanic eruptions. One of the most intriguing mysteries surrounding the end of the last ice age is the Younger Dryas, a period of abrupt cooling that interrupted the general warming trend. This sudden shift in climate conditions has puzzled scientists for decades, as it stands out as a significant anomaly in the Earth's climatic history. While the exact cause of this cold snap is still debated, there is compelling evidence that it was triggered by a massive influx of freshwater into the North Atlantic Ocean. This influx is believed to have originated from the sudden and catastrophic drainage of glacial lakes, which released vast amounts of freshwater into the ocean. This freshwater, likely originating from the catastrophic drainage of glacial lakes like Agassiz, disrupted ocean currents, particularly the Atlantic meridional overturning circulation, which plays a crucial role in transporting heat from the tropics to the North Atlantic. The disruption of these currents had far-reaching effects on global climate patterns. The Younger Dryas serves as a stark reminder of the interconnectedness of Earth's systems and the profound impact that seemingly localized events, like the drainage of a glacial lake, can have on a global scale. It underscores the complexity of our planet's climate system and how sensitive it is to changes. It highlights the delicate balance of Earth's climate and the potential for rapid and dramatic shifts in response to seemingly small changes. Understanding these past events is crucial for predicting and preparing for future climate changes, as it provides valuable insights into the mechanisms driving our planet's climate. As remnants of the Ice Age, glacial lakes scattered across the landscape tell stories of colossal forces that shape the land. These lakes, formed by the retreating ice sheets, continue to define ecosystems, provide fresh water, and shape human life and industry, preserving the legacy of a world once ruled by ice. The glacial lakes that formed during the last ice age have long since vanished, their waters drained away, leaving behind only remnants of their former glory. Yet, their impact on the landscape is undeniable. The Great Lakes of North America, for instance, owe their existence, at least in part, to the scouring action of glaciers and the subsequent infilling of meltwater. Across North America, from the Canadian Shield to the Great Plains, we see the legacy of these ancient lakes in the form of fertile farmlands, vast wetlands and unique ecosystems. The rich soils of the American Midwest, for instance, owe their fertility to the glacial sediments deposited by the overflowing waters of Lake Agassiz. Across continents, subtle yet enduring imprints left by ancient glaciers reveal the powerful reach of the last ice age. From carved valleys and polished rocks to distinct soil patterns, these features serve as reminders of a frozen past, echoing the immense forces that once transformed the Earth's surface. Even today, thousands of years after the last ice sheets retreated, we can still see the evidence of these ancient glacial lakes in the landscape. Across North America, geologists, using a variety of techniques, have mapped out the shorelines of these vanished lakes, tracing their former boundaries and piecing together the story of their formation and drainage. From the air, we can see the remnants of these lakes in the form of ancient beach ridges, now covered in vegetation, marking the former shorelines. On the ground, geologists find evidence of these lakes in the form of lakebed sediments, distinct layers of sand and silt that tell a story of fluctuating water levels and changing environments. The story of glaciers is one of vast, slow-moving giants that sculpted mountains, carved valleys, and reshaped continents. Over millennia, these immense ice sheets advanced and retreated, leaving behind a record of their power etched into the Earth's terrain, a testament to the relentless forces that have shaped our planet's natural history. The story of Glacial Lakes is a testament to the immense power of ice to shape our planet. These lakes, born from the melting of colossal ice sheets, played a crucial role in carving the landscape, redirecting rivers, and influencing global climate patterns. Their legacy lives on today in the fertile farmlands, vast wetlands, and unique ecosystems that characterize North America. As we face the challenges of a changing climate, understanding the legacy of the Ice Age and the profound impact of these ancient lakes provides valuable insights into the interconnectedness of Earth's systems and the potential for both gradual and abrupt change.